Still on vector analysis. In this video, we're going to talk about the gradient of a scalar field or the gradient of a scalar function. And here, we'll be talking about the grad operator. Now, consider a scalar field phi, which is a function of several variables x, y, and z. Phi here is a scalar function, okay? We can determine the gradient of this scalar function. The gradient of phi, grad of phi, or we use the symbol. This symbol is pronounced as del or nabla sometimes. The gradient of phi is equal to this. The partial derivative of phi with respect to x times I plus the partial derivative of phi with respect to y times j plus the partial derivative of phi with respect to z times k. So you can see that the result is a vector function. So the grad operator acts on a scalar field to produce a vector. That is the point. Now, if phi is equal to this 3x squared y plus xyz minus 4y squared z squared minus 3, we are to determine the gradient of phi at the points 1, 2, 1, where x is 1, y is 2, and z is 1. So let us go ahead and determine the gradient of this scalar field. Subscribe, like, and share this video to your friends and to your classmates. As it is, the gradient of phi, okay, is equal to partial phi partial x times I plus partial phi partial y times j plus partial phi partial z times k. So let us determine partial phi partial x first. Okay, what is partial phi partial x? The partial derivative of phi with respect to x. So we're going to differentiate this now, this function with respect to x. That means all other variables will be treated as constants, y and z. So if we differentiate this now with respect to x, we are going to take 3y as a constant. Then differentiate x squared with respect to x. So if we differentiate x squared with respect to x, we are going to have 2x. That's for this. Then let's come here. We are differentiating with respect to what? X. So yz will be taken as a constant, and then we differentiate x with respect to x, and that will give us 1. And here we'll take, okay, 4y squared z squared. There is no x there, so it is a constant. Everything is a constant, and the derivative of a constant with respect to any variable is equal to 0. So differentiate this now to get 0 because it is a constant. There is no term in x here, so as a constant that it is, the derivative of it is equal to 0. So we can say 0. Okay, let's leave it 0. So what do we have now? We have, this is 6xy plus yz. So this is the partial derivative of phi with respect to x. Now, what is the partial derivative of phi with respect to y? That's partial phi partial y. In similar fashion, we'll treat all other variables as constants apart from y. So x and z will be taken as constants, and then we'll differentiate y. So in this case, we have 3x squared y. We are going to take 3x squared as a constant, and then differentiate y with respect to y, and that will give us 1. We'll take xz as a constant and differentiate y with respect to y to get 1 also. Here we'll take minus 4z squared as a constant. So we will now differentiate y squared with respect to y. and that will give us what? 2y. I hope you are familiar with finding derivatives of function. Okay, just in case, if I have a function y equal to ax to the power of n, all right, the y dx, which is the derivative of y with respect to x, is equal to this: n times a, that's n a, times x to the power of what? N minus 1. All right. So when we differentiated y squared with respect to y, and we got 2y, this is how it is. Y squared. Let's differentiate y squared with respect to y. 2 times the coefficient of y squared here, which is 1. So that is 2 times the y to the power of 2 minus 1. Okay, and what would this be? This is 2y raised to the power 1, which is equal to what? 2y. So that is how it is 2y here. All right. So let's go ahead. This is just in case you are probably new to derivatives. You can watch my videos on how to differentiate functions, okay, and you learn better. Now we are here. We kept minus 4z squared as a constant, and we differentiated what? Y squared to get 2y. Now if we differentiate minus 3 is a constant. So the derivative of the constant will actually give us what? 0. So that's out. So let's simplify. We have 3s squared plus x z minus, this is 8, 2 times 4, 8, y z squared. So this is partial phi, partial y. Lastly, what is partial phi, partial z? Partial phi, partial z is equal to this. We are going to differentiate this now with respect to z, keeping x and y as constant. So there is no z term here, or there is no z term here. So it is a constant. And the derivative of a constant is equal to 0. So this is 0. Here we have x, y, z. So we keep x, y as constant. Differentiate z or z with respect to z is going to produce 1. Okay. Here we'll keep minus 4y squared as a constant. Minus 4y squared as a constant. Then differentiate z squared to get 2z. That's, I'm differentiating this now with respect to z, 2z. And the derivative of this one will actually give us what? 0. Okay, so we have xy minus 8y squared z. So this is partial phi, partial x, partial phi, partial y, partial phi, partial z. Now, what is the grad of phi? The gradient of this scalar field. The grad of phi, which is equal to grad of phi, is equal to this. Let's substitute this into this formula. Partial phi, partial x is this. That is what? 6xy plus yz times what? I. Okay. What is partial phi, partial y? This is it. Plus 3x squared plus xz minus 8yz squared times what? J. And plus, this is plus. What is partial phi, partial z? This is it. xy minus 8y squared z times what? K. So this is the vector which gives the gradient of this scalar field. I told you earlier, the grad operator acts on a scalar field to produce a vector. So this is the vector function that we have now. But the condition is that the gradient of phi at this point. So at the point 1, 2, 1, okay, X is equal to 1, Y is equal to 2, and Z is equal to 1. So the grad of phi is equal to this. We have 6. Okay, X is 1, Y is 2. 6 times 1 times 2 is 12. Y is 2, Z is 1. 2 times 1 is 2. Plus X is what? 1. So 3 times 1 squared is 3. X is 1, Z is 1. 1 times 1 is 1. Y is 2, Z is 1. So Z squared, 1 squared is 1. Times 2 is 2. Times minus 8 as minus 16. Minus 16. Okay, X is 1, Y is 2. So 1 times 2 is 2. We have minus Y squared, which is 2 squared is 4. Z is 1. So 4 times 1 is 4. Times 8, that is 32. So we have minus 32 times K. So the grad of phi, I always like to write this, grad of phi is equal to, this is 14i. 3 plus 1 is 4, minus 16 is minus 12. And this will give me minus 30k. So this is the gradient of that scalar field at this particular point. So this is how to determine the gradient of a scalar field, talking about the grad operator. I hope this video is helpful. Keep supporting by subscribing to this channel, like the video and share it with your friends and your course-mates. I am the Complex Analyzer, and I will see you in the next one. Keep following.